Yesterday we finished class going over multiplying radicals, and we're going to re-emphasize that today as part of what we're doing. So we learned how to simplify radicals, where we found the greatest perfect square factor, factored it out, took its square root. Then we used that to multiply, to add. All answers have to be simplified. Today we're going to look at section 10.5, and it has to do with division. You're really not going to get a sense that you're doing any division, but we're going to make sure that we do something called rationalizing the denominator. Now, rationalizing is to make rational. So we're going to have a rule, no square roots in the denominator. We can only have rational numbers in the denominator. Now, I think there is probably a historical reason for that, which doesn't really affect y'all anymore, and if you're taking notes, don't take this down, but I want you to think about this problem, and I ask you to give me a value rounded to say 3 or 4 decimal places. Well, this would be dividing into 1, and somebody tell me the square root of 2. Give me about 3 or 4 decimal places. I know it's 1.41. Like that? Okay, and that's just rounded because it's an irrational number. Now, what would you have to do to divide that? Add a decimal point. You want this to be rational, 1, 2, 3. So you'd have to go 1, 2, 3, add the decimal point, move it up, fill in with zeros, add another 0, and start dividing. That doesn't look like much fun, does it? Okay. Now, today we're going to learn how to turn this statement into this statement. We'll turn their equivalent. We'll talk about the process, how to make that happen. And what would this one be like? I'd be dividing 2 into 1.414. Bring it straight up. Which division problem would you rather do? I hope the second one. The division would be easier because when the divisor is already a nice little rational number, it's easier. Now, it doesn't matter to us today if we grab a calculator. We don't care if it's this one or this one. But historically, it made a difference. That's just one little reason that we do this process called rationalizing the denominator. Make the denominator a rational number. Let's start with number 1, and I will show you the process in the first problem. It says to rationalize the denominator, the square root of 7 over the square root of 10. Obviously, the denominator right now is not rational, and I need to change that. The first thing I look at is, could I simplify something before I get started? It'll be easier if I have a simplified situation, and the answer is no. And I can't reduce the fractional part of it. I can't do anything to it. To rationalize it, here's the process. Do you agree it would be okay to multiply it by the number 1? Can the number 1 take on a lot of different forms? An infinite number of forms. Could it be 5 over 5, 9 over 9, 6 over 6? All of those are the number 1. Well, the form of the number 1 that I'm going to choose is the square root of 10 over the square root of 10. That is the number 1, which means I'm not changing the value of this fraction, just changing the way it looks. Multiply the top. You can multiply radicals. Square root of 7 times square root of 10 is the square root of 70 over. Do you remember from yesterday what happens when you multiply a square root times itself? You just pull the radicand out as a rational number. Now here's the step that we're skipping. The square root of 10 times the square root of 10 is 100, and the square root of 100 is rational 10. No square root anymore. So, last step, again, ask yourself, can I simplify the square root of 70? Is there a perfect square that goes into 70? I don't think 4 goes in there. I don't think there is. If you even just think about all the things that go into 70, 7 times 10, and 10 is 2 times 5, there were no perfect square factors in there. So, done. I can well remember in a calculus class and doing my homework, pencil paper homework in the old days, and turning to the back of the book to check my answer. And before I even checked it, I had gotten this really long answer, and oh, there were radicals in the denominator, so I remembered my process, and I rationalized the denominator, and it took all this work. And then I looked at the back of the book, and they had not rationalized the denominator. So, if we're going to do it, and in this class it's going to be considered bad form if you don't do it. But do not be surprised if you continue in math that at some point somebody says, oh, it's no big deal. For us, it's a big deal. All right, moving on. Number 2. It says to simplify the square root of the fraction 1/3. Well, the first thing that I'm going to do, I like my fractions to be broken into square root on top and square root on bottom. So I have 1 over the square root of 3. I have square root of 1 over the square root of 3 now. And can I simplify any of that? What is the square root of 1? 1. So I might as well take it out of the radical, and I can't do anything with the square root of 3. You might do all this stuff in your head. Now, the denominator has got a radical in it. I need to rationalize it. What form of the number 1 will I multiply by? Right, square root of 3 over the square root of 3. The numerator, 1 times the square root of 3 is the square root of 3. And what's the denominator? The square root of 9, which is 3. Okay, so remember, when you multiply a square root times itself, you could multiply it out, get the square root of 9, but it's equal to 3. And I can't do anything with that fraction. And I almost have a mental checklist. Can I simplify any radicals? Can I reduce the fraction in any way? And the answer to all that's no. All right, let's look at number 3. I have the square root of 49 over x under all into a fraction. All right, I'm going to change it to the square root of 49 over the square root of x. And can you simplify any part of that? Yeah, the square root of 49 is 7. So that's 7 over the square root of x. Well, I can't do anything to anything, so I'm ready to rationalize. What form of the number 1 should I choose? Yeah, square root of x over the square root of x. That gives me 7 times the square root of x over, what is the square root of x times the square root of x? X. You should look, now you can't do anything with this problem, but you should look if you have rational numbers here to just see if you could do some reducing with those. And we haven't had a case where we could, but keep an eye on those. All right, number 4. We have 3 over the square root of 7x. Can you simplify anything before we get started? No. All right, then I'm going to rationalize the denominator by multiplying by the number 1 in whatever form you tell me. The square root of 7x over the square root of 7x. The numerator, and I'm sorry about that x that's still sticking up there. Maybe I'll write the answer down here. What is 3 times the square root of 7x? Isn't it 3 times the square root of 7x? And the denominator? It is just 7x. If you multiplied it out, you'd get the square root of 49x squared, but that is 7x. All right, let's look at number 5. Is this going okay for y'all? All right. Number 5, I have 2 times the square root of 3 over the square root of 5. Can I simplify anything that you see up there right now? No. All right, then I'm going to rationalize the denominator. What am I going to use? Square root of 5 over the square root of 5. There are times in certain areas of mathematics when you need to rationalize a numerator. But that's not, I don't even go over that in this lesson. Okay, so I'm going to get, for the numerator, 2 times the square root of 15 over, you tell me, 5. All right, now you would look. These are the things that should be in your mental checklist. The newly formed radical on top, can I simplify it? Does it have a perfect square factor? And we haven't had a case where we could say yes to that yet. Look at any rational numbers that form a fraction and ask, could I reduce those? Do they have a common factor? And those answers are no, but I think about them. Number 6. It has the square root of the fraction, 5x over 8. All right, the first thing I'm going to do is break it into the square root of 5x over the square root of 8. And every time I've been saying, can I simplify anything? Can I reduce anything? What's your answer? Okay, good. Good observation. The square root of 8 is the first time we've seen a radical in this lesson that can be simplified. I'm going to do it in blue. Okay, so underneath it, simplifying a radical means looking for perfect square factors. And 8 is the same as 4 times 2, with 4 being a perfect square. So it's the square root of 4 times the square root of 2. Can y'all see that blue okay? And that's going to be 2 times the square root of 2. So this is the square root of 5x over 2 times the square root of 2. Okay, we got it simplified. And by the way, if you didn't do that, it would still work out okay, but you'd have to simplify a good bit at the end of the problem and the numbers would be bigger. So it's easier if you do it early. Now, I want to rationalize. What do I multiply by?
2 squared root of 2.
All right, 2 square root of 2 is completely acceptable. It's just bigger than it has to be. Because what's the only thing that you need to turn rational? Square root of 2. So all you have to multiply by is the square root of 2. You would get the right answer with what you were saying. 2 times the square root of 2. You just have to do more reducing at the end of the problem. Does that make sense? Okay, so this is going to be equal to, on the top, I have square root of 5x times the square root of 2, which is the square root of 10x, over On the bottom, first of all, I have this 2. Then I have square root of 2 times square root of 2, which is the square root of 4, or 2. So does everybody see where both those 2's came from? That gives me the square root of 10x over 4. Can you simplify this radical? No. Can you reduce? No, because I don't have rational numbers with common factors. Remember, they're like segregation in numbers. The rational numbers can interact with the rational numbers, and the radicals can interact with the radicals. And in math, that's okay. Okay? Segregation is not bad in math. Trying to make sure I say the right thing. All right. Now, we're going to take a little change by looking at number 7. It says to rationalize the denominator. Now, I'm going to let us make some guesses. So you might want to wait in your note-taking until we decide, maybe with my help, that it's the right guess. Okay? The problem is to rationalize the denominator of 4 over 1 minus the square root of 3. Now, based on yesterday's lesson, I don't know how likely we are to get this. I mean, to guess this, because I don't think I even mentioned this yesterday. All right, I need to rationalize the denominator, but, ooh, I've got a minus sign. That's going to make things different. So, what would you like me to try? I'll try anything. Now y'all are all timid. You don't want to say anything because you think, oh, I guess I'm wrong.
Can we do reciprocals?
Okay. He mentions reciprocals, which if we were in equation mode, that would be perfect. But if I multiplied by a reciprocal, I'm not multiplying by the number 1. Okay? So I can't do that. But thank you for being willing to guess something. Okay. Tell me where.
I did.
Okay.
You think reciprocal, you think
Up.
that doesn't work opposite.
Okay. She's on the right track, even if she doesn't realize it. Okay. What you're going to multiply by. If you multiply, we're going to go ahead and get it right, because I scared y'all into not guessing. Didn't mean to. Because usually when I say that, I don't preface it with, we probably won't get it right. And so everybody's just like, oh, try the square root of 3. And I show that doesn't work. Well, try so-and-so, and that doesn't work. So what you use is not fully the opposite, but you use 1 plus the square root of 3 over 1 plus the square root of 3. I want to take you out of this lesson for just a second and remind you of something. Okay, so I'm going to go away from that page. And do you remember that 2x plus 5 times 2x minus 5? Do you remember what happens when you multiply a sum and difference product? The outers and the inners cancel out. So I get 4x squared. Outer is negative 10x, inner is positive 10x. Those go away, and I have minus 25. I get the difference of squares. Okay, remember that. Do you remember yesterday? Let's suppose I have the square root of 3 minus the square root of 5 times the square root of 3. How about 2 times the square root of 3 minus, 2 times the square root of 5. When we did that yesterday, it was a pretty big process. And because I was fearful that it might be disorganized, I said, okay, let's do FOIL. Product of the first. That's square root of 3 times 2 square roots of 3, which gave me 2 times 3, or 6. Okay, this is from yesterday. Outer product, well, the outer product is the square root of 3 times negative 2 square root of 5. Okay, that's negative 2 square root of 15. The inner product, that is negative square root of 5 times 2 square root of 3, or, negative 2 square root of 15. Okay, somehow I managed to make that happen. And the last is negative square root of 5 times negative 2 square root of 5. Negative times negative is positive. 2 times, what's the square root of 5 times the square root? It's 5, which is 10. Now, when I add all that stuff up, where do the radicals fall in? Where are the radicals in the answer? The outers and the inners? In the middle. Okay, so I had 6. If I add those together, minus 4 square root of 15 plus 10. Okay, now why in the world did I go off on this tangent? Where am I headed with this? Do you agree that if you could make that guy go away, you could add the 10 and the 6, get 16, and you have a nice rational answer? If you just didn't have a middle term. When you multiply a sum and difference, you don't get a middle term. So, back to our lesson. Those of you who are taking notes, you kick in right now. If I multiply the denominators as sum and differences, then I will always get a rational answer. Now, there is a name for the relationship between those two. We talked about reciprocals, we talked about opposites. These aren't really either one of those, but 1 minus the square root of 3 and 1 plus the square root of 3 are conjugates. And you will hear that word again in college algebra. It is a sum and a difference involving radicals. Okay, in the numerator, what kind of multiplication am I going to use? Distributive property. So I have 4 times 1 is 4, and I have 4 times the square root of 3, which is 4 times the square root of 3. Remember yesterday we did distributive property, we did FOIL, we were leading up to this. Now, normally, if I were going to multiply, and I'll put those in parentheses so it makes it look like binomials, I would go down and say first, outer, inner, last. I don't have to, because it's a sum and difference. All I have to do, and I'm going to erase this word just to have more room, all I have to do is look at the product of the first, forget about the outers and inners, and look at the product of the last. That's all I have to look at. What will the product of the first be? What will the product of the last be? It'll be negative 3. Now, let me pause for just a second and make sure that that makes sense to you. Of course, the 1 times 1 is very clear, I hope. For the product of the last, it's a negative times a positive, and it's always going to be a negative times a positive. So it's always going to be minus, and then square root of 3 times square root of 3 popped out as 3. So what is my denominator? It's 1 minus 3, which is negative 2. We rationalize the denominator by multiplying by the number 1 in the form of conjugate over conjugate of the denominator. Now, can you reduce? Okay, this 2 goes into both that term and that term, which you would have to do to be able to reduce. You can't just do partial. So negative 2 goes into 4, negative 2 times, Negative 2 goes into 4, negative 2 times, and there's still a square root of 3. And that's it. I didn't even end up with a fraction this time. But whatever this number is, if there are multiple terms up here, it has to go into all of them. Number 8. I have negative 7 over the square root of x minus a 5. All right, I can't simplify anything, so I'd like to rationalize the denominator. It has 2 terms. When it has 2 terms, what do you have to use? The conjugate. New word, conjugate. All right, what's the conjugate of this denominator?
X plus 5.
The square root of x plus a 5. And that's what you're going to put on top and on bottom. All right, how will you multiply on the tops?
7, negative 7 times square root of x plus negative 35.
Okay.
Minus 2.
All right, he got it exactly. I use the distributive property. Negative 7 times the square root of x is negative 7 square root of x. Negative 7 times positive 5 is negative 35. Over. Because they're conjugates, all I care about is product of the first and product of the last. What will be the product of the first? Square root of x times square root of x. I know x. What is negative 5 times positive 5? Negative 25. And that's what I've got for the denominator, x minus 25. Be careful, don't break the rules of reducing fractions or simplifying fractions, because can you factor the top? Well, the answer is yes. I could have pulled that negative 7 back out, but I just multiplied it. Do you have a 7 as a factor down here? No. Can I reduce the 35 and the 25?
Yes.
No, because 5, although it's a factor of this term, and it's a factor of this term, is 5 a factor of the top? Is 5 a factor of the whole bottom? And when I say that, I'm saying, can you use greatest common factor and take 5 out? No. So it's not a factor. It's a piece of one of the terms. And if you can't do anything with that, and what you could do with that is kind of useless, you leave them alone. Okay? It's tempting, but I'd rather make a big deal about not doing it than let you just fall into that trap. An unreduced fraction is the right value. Might not be in the form somebody likes, but it's the right value. A mistakenly reduced fraction is just wrong. You've changed its value. So I personally err on the side of, if you're not sure, don't reduce it, okay? Or don't try to reduce it. A math lab, yeah, it'll count it wrong, but I usually would not. All right, next one. Rationalize the denominator, square root of 11 minus the square root of 5 over the square root of 11 plus the square root of 5. Now you might look at that and say, oh, conjugates, top and bottom. And then I'd say, oh, doesn't matter. It doesn't affect the problem at all. Conjugates are only significant when you multiply them. Okay, so having said that, what can I multiply by?
Square root of 11 plus minus.
Yes, square root of 11 minus the square root of 5 over the square root of 11 minus the square root of 5. You've multiplied by conjugates. Now the denominator is easy. The numerator, not quite so easy. So what I'd like to do is just come down here and just talk about the numerator for a minute. This is probably going to take up more room than you'd like in a regular problem, but in the notes, I want it to be clear. All right, I'm going to multiply these. I'm going to use FOIL, and the inners and outers are not going to cancel. What's the product of the first? Square root of 11 times square root of 11, which is 11. Okay, outer product. I'm going to multiply the square root of 11 times the negative square root of 5, which is negative square root 55. Now, I hope you're recognizing that I'm multiplying something that looks like a binomial times itself. Do you remember what happens when you square a binomial? What is always going to be true about the outers and inners? They're going to be the same. Outers and inners are always going to be the same. Now, if you don't remember it, it's certainly fine because you multiply the negative square root of 5, I'm multiplying the inners, times the square root of 11, and I get another negative square root of 55, which is negative 2 square root of 55. Last, negative square root of 5 times negative square root of 5. Negative times negative is positive, and it is 5. So when I multiplied the numerator, I get, 11 plus 5 is 16 minus 2 square root of 55. And I'm sorry that's very crowded. I guess I didn't have to make it so crowded. I ended up with only 2 terms because the outers and inners combined, the first and the last were rational, so I was able to write it as that. Now, back up to the problem. The numerator is equal to 16 minus 2 times the square root of 55. And I'm going to move this away just a little bit. Okay. Now the denominators. I don't think I have to go down and do a separate thing because these are conjugates. What's the product of the first? 11. Square root of 11 times the square root of 11 is the square root of 121, which is 11. Always minus. Positive square root of 5 times negative square root of 5 gives me minus 5. So what's the value of the denominator? It is 6. Now, that's the right valued answer. That's the answer. My denominator is rationalized. But can I reduce this fraction?
Yes.
Okay, do you see that this rational term, this rational factor of that term, and this rational term do all share a common factor? 2. All right, so if I divide 2 into the 16, I get 8. I divide 2 into that, I get a minus 1. And I divide 2 into that, and I get 3. So I end up with 8 minus implied 1 times the square root of 55 all over 3. It seems like so far I could just give you one of these problems and it would test almost everything that you're supposed to have learned in this chapter. Is that okay? Do you see why I got to reduce this one and I didn't get to reduce this one? Because there wasn't anything that was in common to all the terms. And there was down here. There. All right. What are we on? 10? I have square root of a plus 3 over 3 times the square root of a minus the square root of b. Well, there's nothing I can do to simplify or reduce before I get going. Since there is a difference down here, what will the conjugate be?
3 square root of a plus square root of b.
Exactly. 3 times the square root of a plus the square root of b. And you do need that 3 because otherwise the outers and inners won't cancel. Okay, so you do need that. Oh, and I've got to have it on top. The bottom looks much easier to do than the top does. All right, I'm going to scoot down. Well, hopefully not too far. Well, I'll do it here and then I'm going to move it. Scoot down on your paper if you're taking notes. I can add lines here in just a second. The numerator. I have the square root of a plus 3 times 3 square root of a plus square root of b. This is just the numerator. Oops. All right, let's do FOIL. Product of the first. Square root of a times 3 square roots of a gives me what? 3a. Square root of a times square root of a gives you a. Rational a. The outer product is square root of a times square root of b, which is the square root of ab. Inner is 3 times 3 square roots of a, which is 9 square root of a. And in this problem, my outers and inners are not like terms. And that's because the two radicals were kind of different formats. This one had a b and this one didn't. So the last, product of the last, 3 times the square root of b is 3 times the square root of b. And there are no like terms. They're all positive. So the numerator is I don't remember. So it is, how about I write it underneath because there's no room. All right, I remember that the first term was 3a. Is it plus square root of ab plus 9 times the square root of a plus 3 times the square root of, oops. Sorry, got to go back. 3 times the square root of b. Is that what we got down at the bottom? Over. All right, bottom conjugates, this shouldn't be a problem. What is 3 square root of a times 3 square root of a? Well, 3 times 3 is 9. Square root of a times square root of a is a. So it's 9a. And out of the last, negative square root of b times positive square root of b. It's b and it's minus. And I can't do that subtraction because I have 9a minus b. And no, you can't reduce. If you look at it, you might start thinking about 3's because I see quite a few things that 3 will go into. 3 will go into this term, this term, this term, and this term, but I didn't point at all the terms, so I can't reduce. I know that was long. What I'd like you to try to do is number 11, and it has to rationalize the denominator of 5 over 1 plus the square root of 7. And this one is much friendlier. I'm going to pause the recording so that you can do that. All right, what did y'all multiply by? 1 minus the square root of 7, 1 minus the square root of 7. All right, on the numerator, distributive properties, so much easier. That gives me 5 minus 5 times the square root of 7. The denominator has got conjugates. The product of the first is 1. The product of the last is negative 7. That means that the denominator's value is negative 6. Is that what y'all got? And you can't do anything. If you don't like negative denominators, which some people, it just looks a little weird, then you could change the sign on the bottom and change the signs on the top. But there's really no need to, because you're not doing anything with this answer. Okay, so that's rationalizing denominators. Remember that we had two different formats. If the denominator involves a sum or difference with radicals, you use conjugates. Otherwise, you just multiply by the smallest radical you can, top and bottom, to rationalize that in the denominator. Okay, so we'll call that one done.